So without wasting time, let me start the agenda for today. Mapping application is the modern enterprises IT environments requires a complex systems architecture wherein hardware system components interact and depend on each other to deliver the necessary functionality. Infrastructure and apps evolve, more lines of code are added to the code base that scales up IT apps and services. We're growing user base running on software-defined, virtualized, or cloud-based IT environments. So mapping applications is crucial to the cloud environment. Discovering these dependencies is critical to understand how the IT environment behaves, which touches many aspects of IT-driven operational environments. Good morning, Vishal.
Good morning, sir.
So what is application mapping? It is a process of discovering the requirements or identifying the interactions and dependencies between the application components and their underlying hardware infrastructure. To ensure that the platform or performs optimally, it's important to discover and map the underlying dependencies. The technology that enables this capability is most commonly called as application mapping. So all the dependencies required to map the application functionality are called application mapping. But application discovery and dependency mapping is another word for it. The management solution that discovers the relationship of application components and underlying components, which maps them to deliver a comprehensive insight into the resource running in IT infrastructure and their dependencies. The general architecture of application mapping is an IT team which does this job over the cloud environment or load balancers, wherein the users are on the other end, where application are leveraged by the users. The networking environment may be on-prem or AWS or Azure or GCP. So the typical architecture is to map the application delivery between the load balancer, application mapping over a network or a cloud environment. It's called application mapping. How does it works? Application mapping. It can be implemented in several ways, ranging from brainstorming and manual amendment of owing to automated discovery of the IT environment ecosystem. These are broad classification, agent-based and agent-less monitoring, but there are other many fewer techniques available to application mapping. But as per your syllabi, these are the topics to be discussed. So agent-based monitoring and agent-less monitoring in the application mapping. Agentless monitoring technique is the traditional way of discovering IP assets by pinging IP address and identifying corresponding devices. Is it? The technique identifies application components, devices, and server systems based on information such as discovery ping rate and discovery device group information. Also established based on known device data. The sweep and poll method is lightweight and allows users to sweep the entire network from a single connected node location. The process may be slow for large-scale data centers, which is a drawback considering that the dependencies can change during the process and leave critical assets undiscovered. Furthermore, discovering app components, particularly in dynamic to the virtualized and cloud-based IT environments, with a limited visibility and control, may be a challenging task in sweep and poll. Network monitoring looks at real-time packet information and captures accurate data on application dependencies. The network flow protocol contains IP traffic information, volume, path, source and destination nodes, other IP flow attributes. Using a protocol such as NetFlow for traffic monitoring has its own disadvantages. NetFlow implementation can impact the performance of devices given its large bandwidth requirement. To address this issue, the data is sampled at intervals, which reduces the demand of bandwidth consumption, but also collects fewer packets information since the unsampled data is not monitored. Additionally, NetFlow containing IP addresses and TCP port data cannot differentiate the application level dependencies. As an alternative, data packets can be captured, but still provide only a limited information collected at the time of porting. The first type, agent on server. Second type, it is agent-based mapping technique. With agent-based monitoring, a software component is installed on the client server to collect the information. The monitoring station at the server side requests the data at periodic intervals to define frequencies that we give as a condition or a predefined policy. The agent monitors incoming and outgoing traffic in real time and can identify the topology changes in application dependency as and when they happen. This capability is particularly suitable for dynamic virtualized infrastructure environments, wherein a lot of virtualized machines are on and off, terminating the 3 or 4 different states of VMs or keep on changing with respect to topology and with respect to time. Additionally, they can differentiate between the apps running on same server instances and the overall cost of running agent is less than is using individual hardware devices to collect the packet data. However, the agent must be installed on every server to ensure the complete visibility. This can ultimately cause the monitoring agents to consume the more computing resources, impacting the server infrastructure and overall cost and performance of your application. Orchestration level mapping is the runtime based automation and orchestration platforms are becoming increasingly popular to manage IT environments. This level of mapping enables IT to provide resources for specific workloads efficiently using advanced software solutions. These solutions combine multiple automated tasks and configurations across application components that utilizes the necessary IT resources. In doing so, the orchestration technologies also keeps a track of application components and the underlying server resources. Together with application performance monitoring, APM, or AIOps, DevOps, and other agentless or agent-based technologies, a hybrid discovery and dependency mapping can both form enables the accurate reporting, maintain optimal cost and performance of monitoring systems. Even with the right application monitoring information available, the organizations must be prepared to proactively manage the risk and prevent the performance bottlenecks. So the 3 key aspects should be considered in devising a playbook guideline to achieve these goals as orchestration level mapping is concerned. Applications and systems, risks and mitigation, feedback and iteration. In applications and systems, obtain a comprehensive information about the applications and systems that can be potentially impacted during your application's runtime. Continuously update the existing dependency. Documentation as a new feature. App components and infrastructure resources are deployed. The other key feature is risk and mitigation. Evaluate and prioritize the risk involved. Analyze the vulnerabilities from a security perspective, performance perspective, and cost perspective. Provide a specific guideline and identify roles and responsibilities among the team members as a part of effective risk mitigation plan. This happens everywhere as an agile methodology or in the risk mitigation plan. Third key factor, feedback and iterate, is constantly evolving as a reinforcement learning during the agile process or application process. The new software components are installed and a new and scalable infrastructure resources are provided. As organizations shift workloads from a legacy on-prem systems to advanced cloud-based infrastructure, these IT environment becomes more complex and dynamic. It is therefore important to follow up with the team members, improve the knowledge base, and invest in right technology resources and practices for application discovery and dependency.